Welcome back to our discussion about solving systems of equations. And in this video, we're going to focus on how do you tackle application problems of systems of linear equations. In other words, how do you solve word problems? And this is where the math really gets relevant, right? Because why do we use math? Well, we use it or we learn it because we want to be able to use it. And we only use it in real life contexts. So I try to be relevant and time sensitive here with this example and kind of a little bit humorous, poking fun at the situation that we're currently in. But here's an example of a real-life context where we could use a system of equations to answer the questions that are given. So whenever you're faced with a word problem or an application problem, the very first thing you're wanting to do is slow down and read the words in front of you. Read them, don't skim them. We live in an age where we skim everything looking for relevant information, but this is a time where you want to slow down and read it. Now, I might even suggest that you read it out loud so that you actually read the entire thing. So let's go ahead and do that. And while we're doing that, we are looking for what is the question being asked in this problem. So let's read. A price gouger has an inventory of items that are in high demand during the COVID-19 virus. In a given day, he sells 253 items and has income of $1,542.50. He sells toilet paper for $5 a roll and hand sanitizer for $7.50 per roll. And hand sanitizer for $7.50 per 8-ounce bottle. Find how many of each item he sold that particular day. Okay, so as we are looking at this, we are interested in what is the question being asked. Okay, so this is the question, right? How many of each item did he sell in that day? So how many rolls of toilet paper and how many bottles of hand sanitizer? Okay, so we're going to use that to define our variables. We're going to think about what information is needed. Almost always, this is going to be what you're going to define your variables to be. So we're going to say, all right, we're going to let T equal the number of rolls of toilet paper sold, and let H equal the number of bottles of hand sanitizer sold. All right, so I've defined variables. Now you can use X and Y if you like. I like to use things that kind of represent what they're standing for. So now look at the information within the problem. You can notice that we've got a couple of different classes of information, right? One of the classes is quantity. We have quantity here with 253 items. If I am interested in knowing how many of each item, and he has a total of 253 items he sold that day, I can set up an equation that models that relationship. Okay, what relationship do we know about quantity? Well, we know that the number of rolls that he sold plus the number of bottles of hand sanitizer that he sold will together equal that 253. Okay, so that takes care of quantity. Now the next thing we're going to think about is what relationship do we know about price? Well, we've got, you see there's 3 items that have to do with price, that have to do with money, right? All right, so we know that he sold toilet paper for $5 a roll, $7.50 per 8-ounce bottle of hand sanitizer, and the total that he made that day, or total income that day, was $1,542.50. Well, we can put that all together in an equation as well. We're going to want to multiply t by 5, because for every roll of toilet paper sold, he's going to get $5. So $5 per roll of toilet paper. And he's going to get $7.50 per bottle of hand sanitizer. And when you add all that up together, he's going to have income of $1,542.50. Well, now I've got a nice system of equations that I can solve using either substitution or elimination, right? And I can solve it using the method of my choice. Now, since I've got t and h isolated, well, almost isolated in that first equation, I'm going to use 1 and use the substitution method. I'm going to say that t is equal to 253 minus h, and then go ahead and sub that into the second equation, and I'm going to solve for h. So when I distribute that 5 through to the 253 minus h, I end up with 1265 minus 5h plus 7.5h is equal to $1,542.50. That's a mouthful. Now if I combine like terms on the left-hand side and bring this remaining constant over to the right-hand side, I am left with a resulting equation that's simple, and it's just 2.5h is equal to 277.50. I can further isolate the h by dividing out the 2.5 and find that h is equal to 111. Now, as we did before, we're going to take that and sub that 111 back in here to find t. So t is equal to 253 minus 111, which will equal 142. So now I've solved for t and h, so I can answer the question. Okay, we know now that he sold 142 rolls of toilet paper and 111 bottles of hand sanitizer on that day that he made such good money. He was actually not making any friends that day, but he was an entrepreneur. Okay, so like we did before, it's probably a good idea to go ahead and check your answers in both equations, but I'll let you do that on your own. So here's another example of problem solving using systems of equations. And like I said before, let's go ahead and read this all the way through. Roberto had 15 coins in nickels and quarters. He had 3 more quarters and nickels. He wrote a system of equations to represent the situation, letting n represent the number of nickels and q represent the number of quarters. Then he solved the system with his rockin' algebra skills. How much money did he have? Well, I don't think he had as much as the price gouger, but we'll see. Okay, so we are already kind of told what he used to represent his variables, right? N is the number of nickels he had, and Q is the number of quarters that he had. So if we know he had a total of 15 coins, we can write an equation using the 15. We can say that N plus Q is equal to 15. And we also know that he had 3 more quarters and nickels. So quarters are bigger than the amount of nickels he had. Nickels plus 3 would equal the number of quarters. Well, we know that this system is set up so that we can solve pretty easily using a substitution, right? Go ahead and substitute that n plus 3 from the second equation into the first equation and solve the result. 2n plus 3 is equal to 15, 2n is equal to 12, and n is equal to 6. Now, subbing that back into the second equation, we can find that q is equal to 6 plus 3, which is 9. Now, I want to know how much money he had. So I'm going to need to do a little bit of calculation. If he had 6 nickels, that means he had 30 cents in nickels. Here we are over here, 30 cents in nickels. And if he had 9 quarters, he had $2.25 in quarters. So he had a total of $2.55. Well, that's a lot of change, but not a lot of money. But that's another example of how to solve problems using systems of equations. We'll see you next time.